The next question is solve the equation square root of x squared minus 4 plus square root of x squared plus 4x plus 4 equals square root of 2x squared plus 4x. There are at least two standard ways of solving this question. Let's go ahead and solve with the first method. A normal student will approach this question by squaring both sides. So we'll start by squaring both sides. We have open bracket square root of x squared minus 4 plus square root of x squared plus 4x plus 4 close bracket all square equals square root of 2x squared plus 4x squared. Note here, the first root is linked to the second root by addition, so you can't give them their separate squares. It's not allowed when they are linked by addition. But for this, although the algebraic expressions, which is 2x squared and 4x is linked by addition, they are under a square root. So the situation here is different from the situation here. And for the left, you have to open the bracket. It's like saying a plus b all square. The result is a squared plus b squared plus 2ab. Or you can have it as a squared plus 2ab plus b squared. It just depends on how comfortable you are with any of the formulas. So let's go with the first one. Your a, as in this case, is square root of x squared minus 4, while your b is square root of x squared plus 4x plus 4. Now we'll start with our a squared. A squared means square root of x squared minus 4 all squared plus b squared is square root of x squared plus 4x plus 4 close bracket square. That's your b square. Then you have plus 2ab plus 2, you can use your dot as times a, that's square root of x squared minus 4 times your b, which is square root of x squared plus 4x plus 4 equals, on the right, you can say your square cancels your square root. Since the two terms are under the square root, not minding that they are linked by addition, you have the result as 2x squared plus 4x. On the next line, starting from the left, you have your square cancel your square root. You'll be left with x squared minus 4 plus your square also cancelling your square root. You'll be left with x squared plus 4x plus 4 plus you have 2 times. Since this is under square root and this is under square root and they are linked by times, it's like saying square root of a times square root of b can be a big square root a times b. Same applies to this. You have a big square root. You have to be careful here. You have x squared minus 4 in one bracket times x squared in second bracket plus 4x plus 4 close bracket equals 2x squared plus 4x. On the left, you can work with the ones without square root by collecting like terms. You have that as x squared plus x squared. You take this x squared, you add it to this x squared. Then you go for the x, you have plus 4x. Then you have minus 4, you go to the constant or the numbers without x or a letter. You have minus 4, then you go and pick this plus 4. You're done with that. This 2 is linked to this in the root by times, so you can't add it, so you still have plus 2 times square root of x squared minus 4 in one bracket. In second bracket, x squared plus 4x plus 4 close bracket equals 2x squared plus 4x. You go back to the left, you have 1x squared plus 1x squared, that will give you 2x squared plus 4x. Then you have minus 4 plus 4. You're only 4, you have 4, the result is 0. So you have it as 0, this goes off. Then you still have your plus 2 times square root of x squared minus 4 in one bracket, and in the second bracket, x squared plus 4x plus 4 close bracket equals 2x squared plus 4x. On the next line, we move this plus 2x squared and plus 4x to the other side. We're trying to make our work easy by taking out the easier ones. We can't take out this 2. This 2 is linked to this by times. We have to divide both sides by 2, and we don't want that complication at this time. So let's take this 2 to the other side. We have 2 times square root of x squared minus 4 in one bracket, x squared plus 4x plus 4 close bracket in the second bracket equals 2x squared plus 4x. Now you know this is plus 2x squared. You're taking it over the equals to sign, it turns to minus 2x squared. Minus 2x squared. Then this plus 4x becomes minus 4x when it crosses the equals to sign to the other side. On the next line, we collect like terms on the right and we solve. We have 2 times square root of open bracket x squared minus 4 close bracket in second bracket x squared plus 4x plus 4 close bracket equals, here we collect like terms. You have 2x squared, this 2x squared owns this minus 2x squared plus 4x, that's this 4x, then minus 4x. We have 2 times square root of x squared minus 4 in one bracket, x squared plus 4x plus 4 in second bracket equals 2x squared minus 2x squared is like x minus x is like 2 minus 2, 1 minus 1 is 0. So this turns to 0. Then you have plus 4x minus 4x. It's still the same thing, like plus 4 minus 4, 4 minus 4 is 0. So the outcome on the right is 0. Next, we have to get these 2 off. We divide both sides by 2 since it's linked by times to the expression under the root. So we divide both sides by 2. 2 cancels 2. Then 0 divided by 2 is 0. So you'll be left with square root of open bracket x squared minus 4 in one bracket times in second bracket x squared plus 4x plus 4 close bracket equals 0. 0 divided by 2 is 0. At this point, we can get the square root off by squaring both sides. We square both sides. We have in open bracket square root of in open bracket x squared minus 4 close bracket in second bracket x squared plus 4x plus 4 close bracket. In the bigger bracket, square equals 0 square. We've squared both sides. On the left, the square cancels the square root. You'll be left with x squared minus 4 in bracket times in the second bracket x squared plus 4x plus 4 close bracket equals 0 square is 0. At this very point, there are 2 ways of solving this question. You can choose to open the bracket. That means you multiply this x squared by this x squared by this 4x, and this x squared by this 4. Then you multiply the minus 4 times the x squared, the minus 4 times the 4x, and the minus 4 times the plus 4. Then you have a polynomial with x to the power of 4. Then you start solving to get your answer. But that's quite tedious. You can, at this point, when you have a situation like this, use an alternative method, which is the same in method as equality of surds. It's also applied when you're factorizing. Let's say you have a question, you have x squared plus 5x plus 6. And you have gotten down to the point after factorizing x plus 2, x plus 3 equals 0. At this point in factorizing, you say x plus 2 equals 0 or x plus 3 equals 0. Now, when you're having 2 separate brackets multiplying themselves equals to 0, that means you can equate both of them to 0. Same applies to this. Not minding that x here is to the power of 2, unlike this where x is to the power of 1. Now you can equate x squared minus 4 to 0 and also this value to 0, just like you do here. It's allowed in math. It's a method in math. You have x squared minus 4 equals 0, or x squared plus 4x plus 4 equals 0. You solve for x on both sides. You can simply say x squared equals 4. The minus 4 crosses the equals to sign and turns to plus 4. Then you're looking for x on your left. You introduce square root to both sides to get the square of the x. You square root this and you square root this also. You know, the square root of 4 is not just 2, is plus or minus 2, because plus 2 times plus 2 will give you 4, and also minus 2 times minus 2 will give you 4. So the square root of 4 is plus or minus 2. Or on the other side, since the coefficient of x squared is 1, therefore you concentrate on these 4. 2 numbers that you multiply to give you 4, yet when you add them, it gives you plus 4. That's 2 times 2. To save our time, you should be able to factorize by now. And if not, you can watch factorizing questions in WAEC, Neco-Becker and the likes. So the result of factorizing this will give you x squared plus 2x plus 2x plus 4 equals 0. Now you group them in twos, then you find what is common in the first bracket. That's x. You'll be left with x plus 2. In the second bracket, you have 2 common in them. You take plus 2, you'll be left with x plus 2 in close bracket equals 0. Since they are the same, you take one of the x plus 2. Then in the second bracket, you join this x with this plus 2. X plus 2 equals 0. Now at this point, you equate them to 0, just like equality of surds, as it's also called equivalent method. So you say x plus 2 equals 0 for the first bracket, or x plus 2 equals 0 for the second bracket. So you have x equals minus 2, the plus 2 crosses the equals sign and turns to minus 2, or x also equals minus 2, the plus 2 crosses the equals sign and turns to minus 2. It seems as if you have 4 answers, but only 2 of them are relevant. You can simply say there are 2 answers, because for the first one you have x equals plus or minus 2. That means x equals plus 2 or minus 2. For the second one, x is minus 2 or minus 2. That's for this one. So you simply just have 2 answers. You say x equals plus 2 or minus 2. This value is minus 2 and the other 2 values are minus 2. So his x is plus 2 or minus 2. We are done with this, but we need to test if both values would satisfy the equation or if only one of them will. But at least one of them should. We know x is 2 or minus 2. We are inserting both values into the original equation to see if both of them will answer or solve the question. Let's start with plus 2. You have square root of, you're now changing your x to 2. So you have 2 squared minus 4 plus square root of 2 squared, that's x squared, plus 4 times 2, that's 4x. The 4 and the x are linked by times, so it's 4 times 2, be careful. Plus 4 equals square root of, you have 2 times, the value of the x is 2 squared plus 4 times 2. This is 4x, that's 4 times 2. Let's go on and solve. You have square root of 2 squared, that's 2 times 2, that's 4 minus 4 plus square root of 2 squared. This 2 squared is 4 plus 4 times 2, that's 8 plus 4 equals square root of 2 times 2 squared is 2 times 2, that's 4 plus 4 times 2, that's 8. On the next line, we say square root of 4 minus 4, that's 0, plus square root of 4 plus 8, 12 plus 4, that's 16, equals square root of 2 times 4, that's 8, 8 plus 8, that's 16. On the next line, square root of 0 is 0, so you can lay it off, then plus square root of 16 is 4 equals square root of 16 equals 4. So we can see the value of x is 2 satisfies the equation because they have the same value on the left and on the right. Next, we go for the value of x equals minus 2. So you have x equals minus 2. We go back to the original equation. Square root of, you have minus 2 squared minus 4, you can put this in brackets, plus square root of, your x is minus 2, so you have minus 2 squared plus 4 times minus 2. When you have a negative, you have to be very careful. Then plus 4 equals square root of 2. Your x in this case is minus 2 squared plus 4 times minus 2. On the next line, you have square root of minus 2 squared is minus 2 times minus 2. That will give you plus 4 minus 4 plus square root of minus 2 squared is minus 2 times minus 2. That's plus 4. At this point, you should be careful on what sign comes next. Don't just jump and write plus. That's plus 4 times minus 2. Go with the signs first. Plus times minus is minus. Then 4 times 2 is 8. Then you still have your plus 4 equals square root of 2 times minus 2 squared is 4 or plus 4. That's minus 2 times minus 2 will give you plus 4. You don't also jump on the sign on this one. You have plus 4 times minus 2. Plus times minus will give you minus. 4 times 2 will give you 8. You have to be very careful here. On the next line, square root of 4 minus 4, that's 0, plus square root of 4 minus 8 will give you minus 4, plus 4. That's minus 4 plus 4 will give you 0. You can use your calculator to do this. Equals square root of 4 times 2 is 8. 8 minus 8 is 0. Square root of 0 is 0 plus square root of 0 is 0 equals square root of 0 is 0. On the left, 0 plus 0 is 0 equals 0 on the right. Since what is on the left is the same as what is on the right, therefore the value of x is minus 2 also satisfies the equation. Therefore, x is 2 or minus 2 solves the question. As said earlier, there's a second method to solving this question, and we will apply it to solving this question.